Combination. Combination is a manner of selection of items in which the order is irrelevant. Unlike permutation, the order of arrangement in combination does not matter. It is given by n combination arrow is equals to n factorial over n minus arrow factorial arrow factorial, where n is the number of given objects and arrow is the number of objects required. Let's take an example. Example 1. A board has 5 directors, A, B, C, D, and E. If committees of 3 members each are to be constituted, how many committees are possible, and list them? A. If A is the chairman, how many committees will involve him? B. How many committees will include 2 particular members, say both D and E? C. How many committees will include any 3 particular members, say A, C, and E together? From the questions, there are 5 persons, and they are A, B, C, D, and E. The committee is made up of 3 members. From the information so far, the number of objects given is equals to 5. And the number of required objects is 3 because we need 3 members out of these 5 members to form the committee. So the question is, how many committees are possible? How do we know if this problem is a combination problem or a permutation problem? We observe that we are asked to find how many committees are possible. Now let's take A, B, and C for example to form a committee. Let's assume that A is Abel, B is Bethel, and C is Cynthia. If we arrange these names to be Bethel, Cynthia, and Abel, or we use this arrangement Cynthia, Abel, Bethel, we observe that they're all the same. This committee here is the same as this committee, is the same as this committee, because they contain 3 persons which are Abel, Bethel, and Cynthia. And that's why the order of arrangement does not matter, because they contain the same persons. So it implies that ABC is the same thing as BCA, and it's equals to CAB, because they contain the same persons. That's why in combination, the order of arrangement does not matter, they're all the same. But assuming we're dealing with permutation, then this arrangement is different from this one, is different from this. But in combination, they're all the same because it contains the same persons. Now let's go back to the problem. Now the formula for combination is n combination arrow is equals to n factorial all over n minus arrow factorial arrow factorial. Now n is 5 because there are 5 persons altogether. Combination 3 because we just need 3 persons to form a committee. It's equals to n is 5 factorial all over 5 minus 3 because it's n minus r factorial, then 3 factorial, which is this arrow factorial here. So we have that 5 combination 3 is equals to 5 factorial all over 2 factorial, 5 minus 3 is 2, then 3 factorial. Now we're going to simplify this further. This will be equals to 5 times 4 times 3 factorial all over 2 factorial times 3 factorial. We stop at 3 because there's 3 factorial here. So this 3 factorial will cancel 3 factorial. Now this will gives us 5 times 4 all over 2 factorial is 2. And this is equals to 2 here 1, 2 into 4 is 2, 5 times 2 is 10. So it means that 10 committees can be formed. From the question, we have to list out these 10 committees. So from those 5 persons, A, B, C, D, and E, we are going to choose 3 at a time in such a way that we won't repeat any of the committee. So let's proceed. Well, you know that the number is 10. Now the committee that are made up of A, B, C, D, and E. Now, let's start with A, B, C. So we must be careful not to write a committee that is made up of A, B, C again. So the next can be A, B, D. The next one can be A, B, E. A, C, D. This is another committee. I've not listed anyone with A, C, D before. So proceed. A, C, E is there. Then we have A, D, E. So I believe that we have exhausted A. We can't have A in the combination anymore. So let's start with B now. B, C, D. We have B, C, E. Then we have B, D, E. It's another combination. And so far we have 9 committees. And we have not repeated any of them. But from our calculation, we're supposed to have 10. So we have 1 to go. And the last one will be C, D, and E. So these are the 10 committees. These are the 10 ways we can arrange them without repeating any specific committee. Since we already have A, B, C, then B, A, C is not allowed. Why? Because A, B, C is already here. So these are the 10 committees that we can choose from those 5 directors. Now let's move on to A. In the A part of the question, if A is the chairman, how many committee will involve him? Remember that we have 5 members, which are A, B, C, D, and E. From these 5 members, N is equals to 5 and R is equals to 3. 5 because there are 5 members, 3 because we are going to choose 3 out of these 5 members to form the committee. But now a condition is given, and the condition is A is the chairman of the committee. So A is already selected from the committee. So since A is already selected, now we are going to choose from these 4 other directors, which are B, C, D, and E. We're no longer interested in A. So therefore, N becomes 5 minus 1. We need to subtract A from it because A is there already. A has been selected. So it becomes 4. So now we're using 4 for N. And out of this 3, since A is already selected, we're going to choose 2 members from C to E that will join A. So also subtract 1 from 3, which becomes 2. So we're going to work with N is equals to 4 and R is equals to 2 to get the number of committees that can be formed when A is involved. Now remember that N combination R is equals to N factorial all over N minus R factorial R factorial. So this gives us 4 factorial all over 4 minus 2 factorial 2 factorial. If we simplify further, we have 4 factorial all over 2 factorial 2 factorial. From the previous page, we stop at 4 factorial all over 2 factorial 2 factorial. Let's simplify further. This is 4 times 3 times 2 factorial. We stop here because we have 2 factorial at the denominator. Of course, 2 factorial cancel 2 factorial. So we have 4 times 3 all over 2. Of course, 2 will go into 4 2 times. So we're left with 6. Hence, there are 6 committees which can be formed when A is the chairman. Now, let's move over to B. How many committees will include 2 particular members, say both D and E? Now, remember that we have A, B, C, D, and E. The number of directors is 5. The number of directors required is 3. But out of those 5, the condition in B is that D and E, they are already chosen. So, we are going to choose the last member from A, B, and C. So out of this 5, we'll subtract 2 from it because D and E is already choosing, and we're left with 3, which are A, B, C. We're going to choose 1 from this A, B, and C. And we require 3 before, but now since 2 are choosing, we'll subtract 2 from it, we're left with 1. So out of these 3 ABC, I'm going to choose 1. So using n combination arrow is equals to n factorial all over n minus arrow factorial arrow factorial. Remember that n is 3 and arrow is 1. So we have 3 factorial all over 3 minus 1 factorial 1 factorial. If we simplify further, it becomes 3 factorial all over 2 factorial 1 factorial. And this gives us 3 times 2 factorial all over 2 factorial times 1. Obviously, 2 factorial cancel 2 factorial, we're left with 3 over 1, which is equal to 3. So there are 3 committees which can be formed, which includes D and E. Now let's move over to the C part of the question. In the C part of the question, how many committees will include any 3 particular members, say A, C, and E together? Now remember that we have A, B, C, D, and E. N is equals to 5 and R is equals to 3. But the condition in C is that A, C, and E are already choosing. So if A, C, and E are already choosing, this will be 5 minus 3, so we'll be left with 2. So I'm going to choose from B and D. Then we require 3 persons, but 3 persons are already choosing, so 3 minus 3, which is equals to 0. This just implies that out of B and D, we're not going to choose any from them because the number of directors required is 0. But let's solve it though. Recall that n combination arrow is equals to n factorial all over n minus arrow factorial. N is 2, arrow is 0. So if we solve further, we have 2 factorial all over 2 minus 0 factorial. So this becomes 2 factorial all over 2 factorial 0 factorial. Now recall 0 factorial is equals to 1. So let's solve further. It becomes 2 factorial all over 2 factorial times 1. 2 factorial cancel 2 factorial, will be left with 1 over 1, which is equals to 1. So a committee that's made up of A, C, and E is only 1. Since there are just 3 members, it's obvious that the answer will be 1. We have solved number 1. Let's move to question number 2. Example 2. A committee of 3 boys and 4 girls is to be formed from 5 boys and 6 girls. How many committees are possible? If one of the girls refuses to serve if a certain other girl is chosen, how many committees are possible? If one of the boys does not want to be in the same committee with 2 particular girls, how many committees are possible? From the question, there are 5 boys and 6 girls, and a committee of 3 boys and 4 girls is to be formed. Now, how many committees are possible? So, it's obvious that in a place of boys, the number of persons given is 5 because there are 5 boys and we require only 3 from the 5 boys. And in place of girls, the number of persons given is 6 and we require 4. Now, we need to take note of this word here, and. When we make use of and, we'll use times. If it is and, it's times, but if the expression is or, it's plus. It also works in probability, and is times or is plus. So, since it's and, it means we're going to multiply the answer we have for boys with that of the one we have for girls. So let's proceed. Now to get the number of committees, we make use of n combination arrow, which is equals to n factorial all over n minus arrow factorial. So we are going to multiply the number of committees of boys by that of the number of committees of girls. So for that of boys, it is 5 combination 3 by that of girls, which is 6 combination 4. If we simplify this expression, it's going to be 5 factorial all over 5 minus 3 factorial, times, that of guess, it is 6 factorial all over 6 minus 4 factorial, 4 factorial. If we simplify this further, it becomes 5 factorial all over 2 factorial, 5 minus 3 is 2, times 3 factorial, which is 3 factorial here, times 6 factorial all over 2 factorial. 6 minus 4 is 2, times 4 factorial. From the previous page, we stop at 5 factorial all over 2 factorial times 3 factorial times 6 factorial all over 2 factorial times 4 factorial. Now let's simplify further. It becomes 5 times 4 times 3 factorial all over 2 factorial times 3 factorial. We stop at 3 factorial because there's 3 factorial here, times 6 times 5 times 4 factorial all over 2 factorial times 4 factorial. We stop at 4 factorial because there's 4 factorial here. Of course, this 3 factorial, we cancel 3 factorial, 4 factorial, we cancel 4 factorial. So we'll be left with 5 times 4 all over 2. 2 factorial is 2, times 6 times 5 all over 2. If we simplify further, it becomes 5 times 2, because 2 here 1 turn to 4 is 2, so we're left with 2. And likewise, 2 here 1 turn to 6 is 3, so this is times 3 times 5. Now this become 10 times 15, and obviously this become 150. So there are 150 ways of forming these committees. So now we know that there are 150 ways. Now assuming we're going to list them out, let the 5 boys be B1, B2, B3, B4, and B5. And then 6 girls, let the 6 girls be G1, G2, G3, G4, G5, and G6. We need 3 boys and 4 girls, so the first combination can be B1, B2, B3, which are 3 boys, then 4 girls, G1, G2, G3, G4. This can be one of the committee. When the second committee will be B1, B2, B4, then G1, G2, G3, G5. The third committee can be B1, B2, B5, then G1, G2, G4, G5. The list keep on going. The total number of committees we can form from these will amount to 150. 150 ways if we continue with those combinations. Now let's move over to the B part of the question. In the B part of the question, it is, if one of the girls refuses to serve if a certain other girl is choosing, how many committees are possible? Now, let's try to understand this question. Now, a particular girl, let's say G1, refuses to serve when G4 decides to serve. So anytime there's G4, G1 won't be there. So it means that in the combination, there must not be G4 and G1, because anytime there's G4, G1 will not serve. Hence, we need to find out how many of this committee out of this 150 does not contain G1 and G4 at the same time. For example, the committee number 1 contains G1 and G4. Committee 2 contains G1 but it's not G4. Then committee 3 contains G1 and G4. So we need those ones that does not contain G1 and G4 at the same time. Does not contain these 2 girls at the same time. The second committee here is one of them. Those committees that contain G1 and G4, we need to cancel them out. Obviously, we can't really list them all to 150. That will take us like 2 hours. But the first thing, we need to understand what the questions involve. That we need those committees that did not contain G1 and G4, since we are using G1 and G4 for an example. Number 1 contain G1 and G4, so we'll cancel it. Number 3 contain G1 and G4, we cancel it. And the easiest way to solve this question is, first of all, we need to find out the number of committee that contains G1 and G4. It's easier to solve that problem. Number of committee that contain G1 and G4. Once we're able to get the number of committee that contain G1 and G4, we'll subtract it from the total number of committee, which is 150, and then we'll get our answer. So let's find the number of committee that contain two particular girls, and let these girls be G1 and G4. Now remember that for boys, n is equals to 5 and arrow is equals to 3. And for girls, n is equals to 6 and arrow is equals to 4. So since two girls are already choosing, and let's say G1 and G4 are choosing already, so out of these 6, we are going to select just 4, because 2 are already choosing. 6 minus 2, 4. So we're using 4 for n now because 2 of the girls are choosing already. Then, out of this 4 required, 2 is already choosing, so minus 2 becomes 2. So we're looking for the next 2 girls out of the 4 other girls. From here, y for boys is still 5 and 3 because it does not really affect number of boys. Simply because 2 girls are choosing, we subtract 2 from 6 and subtract 2 from 4. So we're going to solve with n equals to 5, r equals to 3 for boys, and n equals to 4, r equals to 2 for girls. Now if we do that, we have n combination arrow of boys times n combination arrow of girls. This will give us 5 combination 3 times 4 combination 2. Now when we solve this down, it becomes 5 factorial into 5 minus 3 factorial, 3 factorial, times 4 factorial into 4 minus 2 factorial, 2 factorial, 5 factorial all over 2 factorial, 3 factorial, times 4 factorial all over 2 factorial, 2 factorial. If we simplify further, we have 5 times 4 times 3 factorial all over 2 factorial times 3 factorial times 4 times 3 times 2 factorial all over 2 factorial times 2 factorial. Of course, 3 factorial cancel 3 factorial, 2 factorial cancel 2 factorial, so we have 5 times 4 over 2 times 4 times 3 over 2. This becomes 5 times 2, because 2 here 1, 2 into 4 is 2. 2 here 1, 2 into 4 is 2 also, times 2 times 3. So we have 10 times 6, which gives us 60. Now this implies that out of these 150 ways of forming this committee, 60 of them contains these two particular girls, which are G1 and G4. So since 60 of them contain two particular girls, the number of committee that does not contain that two particular girls will be 150 minus the 60 that contain those two girls. So the answer becomes 150 minus 60, and this will give us 90. So there are 90 of the committees that can be formed where those two girls will not appear. So let's move on to the C part of the question. The C part of the question is, if one of the boys does not want to be in the same committee with two particular girls, how many committees are possible? So now let's go back to the list of committees. So in this time around, one particular boy, let's say B2, does not want to serve when two other girls, let these two girls be G2 and G3 are serving. So anytime G2 and G3 are serving, B2 will not be there. So it simply implies that we are going to take away all the committees that contain B2, G2, and G3. So any committee that contain B2, G2, and G3 at the same time, we'll take them out. Like the first one here contain B2, contain G2 and G3, so we'll cancel it. The other one contain B2, G2, G3, we'll cancel it as well. The third one contain B2, G2, but there's no G3 here. So in this case, this is one of the committees that is needed. So we're going to check the entire list and take away all the committee that contains B2, G2, and G3, because these three persons cannot serve at the same time. And of course, we don't need to write out all the 150 committees and start cancelling them one by one. All we have to do first, just as we did the previous one, is to find the number of committees that contain B2, G2, and G3. Once we have the number of committees that contain B2, G2, and G3, we'll subtract it from 150, and that will be the answer. So now let's go back. Now remember that the number of boys is n is equals to 5 and arrow is equals to 3, while that of girls n is equals to 6, arrow is equals to 4. So in this time around, we're looking for the number of committees that contain one particular boy and two particular girls. So if one boy is already choosing, we subtract one from here, subtract one from here. And if two girls are choosing, subtract 2 from here, subtract 2 from here. So we'll be left with n is equals to 4, arrow is equals to 2, and n is equals to 4, arrow is equals to 2. So if we solve them, we have n combination arrow of boys times n combination arrow of girls. So for that of boys, become 4 combination 2 times 4 combination 2. This is 4 factorial into 4 minus 2 factorial 2 factorial times 4 factorial into 4 minus 2 factorial 2 factorial. It becomes 4 times 3 times 2 factorial all over 2 factorial times 2 factorial times 4 times 3 times 2 factorial all over 2 factorial times 2 factorial. 2 factorial cancel 2 factorial, 2 factorial cancel 2 factorial. We'll be left with 4 times 3 over 2 times 4 times 3 over 2. In the previous page, we stopped at 4 times 3 over 2 times 4 times 3 over 2. This becomes 2 times 3 because 2 into 4 is 2 times 2 times 3 because 2 into 4 is also 2. And this gives us 6 times 6, which is equals to 36. And this implies that out of the 150 committees that can be formed, 36 of them contain one particular boy and two particular girls. So the number of committees that does not contain a particular boy and two particular girls will be 150 minus 36, which is 150 committee minus 36 committee that contain that particular boy and two girls, which is equals to 114. So there are 140 committees that does not contain a particular boy with two particular girls, and this becomes the answer. Do you find it difficult to expand an algebraic expression whose power is I like 5, 7, 10? If so, the next video will interest you. It is Pascal triangle. Pascal triangle will help you to expand an algebraic expression with I powers. The link of the video is at the top of this video. You can click it to access my next video. If you have any question on combination and permutation, feel free to ask me on WhatsApp. Meanwhile, subscribe to my channel, like and share this video. I will see you in my next video.